Okay, so we're working with rational numbers. So numbers that can be written as a comparison of two integers expressed as a fraction. So on our vocab sheet, we can fill out rational numbers with that definition. So I'm going to go ahead and complete this graphic organizer. A rational number is a fraction, or it's a repeating decimal, or a terminating decimal. Any of those can be a rational number. So an example would be a percent, decimal, fraction. I'm going to go ahead and not simplify that one, or a mixed number, 3.5. A rational number in a ratio can be a fraction. And it's just a comparison of two numbers is what a ratio is, and similarly that is a fraction. So we have some information here on this page, some more about rational numbers. We kind of went over this similar graphic organizer yesterday, so I'm not going to spend too much time on that. And we're talking about repeating decimals here, that if something is repeating like 636363, that we make sure we get the bar notation over both of the repeating digits, and it's not 636 or 6363. We pick the shortest and we put a bar over that. So we have two more vocab words here. Repeating decimal is the decimal form of a rational number, and terminating is a decimal that ends. It's a decimal that ends. So if you want to write that instead of that other has a repeating digit of 0, that's fine too. So in order to write some of these as a decimal, instead of using our calculator, and if we don't know these off the top of our heads, we're going to use long division. So when we long divide fractions, setting up our bar here, the top number goes on the outside, the bigger number goes on the inside. And so then we're going to, that's not right. The 8 goes on the outside and the 5 goes on the inside, because 8 does not go into 5. So we put a 0 up there, sorry. So 5, the numerator goes on the inside. The divisor goes on the outside. So 8 goes into 5 0 times, so we put a 0 up there. Bring our decimal, we add a 0. 8 goes into 56 times, and that gets us to 6 times 8 is 48. Subtract, we're left with 2. We add another 0, bring a 0. 8 goes into 22 times to get us 16. Multiply, bring it down. Subtract these two numbers, we get 4. Bring down another 0 that we can add as many zeros up here as we want. 8 goes into 45 times. That's going to come out even. We know we're done. Another way to do this is to know if you know what 1/8 is, and then multiply that by 5. But I didn't know what that one was. Now this one we talked about in class, 2/3. Since I know what that one is, based on what we talked about in class, I can just rewrite that as negative 1.6. It was repeating. When we use bar notation, we just pick the first digit and put a bar over it. Some of these we're going to know off the top of our head. We don't need to use long division. If we don't need to use long division and we know it off the top of our head, we'll just keep it. We talked about this one in class the other day too, 0.75, 3/4 of a dollar. Now I don't know this one off the top of my head, so if I can set this up correctly, we put the 2 on the inside, 9 on the outside, and I have to remember that this has a negative on it, so when we come to that at the end. 9 does not go into 2, so I put a 0, and I bring a decimal, and I add some zeros. 9 goes into 20 twice, gets me to 18. Subtract, I'm left with 2. Bring it down, bring my 0 down. 20, again, 2 times. 18, subtract. Okay, I think we see a pattern here, that this ends up being a bunch of 2's. So we can rewrite that, not forgetting our negative, as negative 0.2 repeating, only picking one digit to repeat. Now this next one, an easier way than doing long division, and because I see this is as 25, I can easily get that to 100 by multiplying by 4. So I'm going to come up with an equivalent fraction. So multiplying the denominator by 4 gets me to 100. The numerator by 4, 13 times 4, 52. So I know that that is 4 and 52 hundredths, or 4 and 52 hundredths. So I write it like that. Now this one, I might not know in my head, so I would use long division, not forgetting that 3. But I'm going to go ahead and do that really quickly. 11 on the outside, 1 here. 11 does not go in, so we would repeat what we've done before. 11 doesn't go into 10 either, so another 0. Another 0 goes into 100 9 times to get me to 99. So I subtract, I get 1, bring down a 0, can't go in, bring down another 0. Looks like I'm going to have the same problem of the repeating. So 3.09 repeating. All right. Moving on to page 2. When we're working with word problems, I'd first create the problem first. So I'm gonna get some lead here. The problem first. I've got some new color there. So in recent seasons, St. Louis Cardinals first baseman Albert, that guy, had 175 hits and 530 at bats. To the nearest thousandth, find his batting average. So they're asking us to divide these. So 530 into 175. And then I would have you go through the long division. We would do that. You can do that. We'll just set up letter E. 6 out of 36. So 6 out of 36 would look like that. We're setting up that ratio. Oh, dang it. 6 into 30, 36 into 6, and how we set them up. Or you could simplify that to 1/6 if you know that off the top of your head. And then we would do the long division. I'd let you take care of that. Now, when we're given decimals, we write them as fractions. I just say write it as you read it. When we were taught place value, we'll just write it as we read it. So instead of 0.45, technically this is 45. Oh my goodness, 45 hundredths. And then we could simplify that. We can take out a 5, and we'd end up with 9/20ths, and we can't simplify that anymore. Now this is not 0.85, but 85 hundredths. And then we could reduce that and take out a 5 as well. So I know the bottom is 20, 85, 5 goes into 85, let's see, 17 times. So 17/20ths. This is 625 thousandths, so 625 thousandths. I know that I can take out a 25. I don't know those off the top of my head. So we could use our calculator to help, but I'm just going to go ahead and leave it like that. You can come up with the answer since I didn't bring a calculator up here. Now this is not 3/10ths, not 3 hundredths, but 3 thousandths. And I know that that cannot be simplified because 1,000 is not divisible by 3. Excuse me. We're moving on to some decimals that are repeaters, but we have to rewrite the repeating decimal as a fraction, which is different than what we just got done doing. So here are some steps that I've come up with that seem to help. So I would rewrite the repeating decimal out a few places, set a variable, that's a letter, equal to the rewritten number, figure out the place value of the repeating number, and you'll see that what I mean in a second. We're going to multiply both sides of the equal sign by whatever place value has been repeated. It's probably going to be a 10 or 100. And then we're going to subtract x from both sides and solve for the variable. Well, you don't have to use x, but I happen to use x. So let me show you what I mean. Slide 8, number 5, says write 0.5 as a fraction in simplest terms. So I would rewrite 0.5 out a few places, probably 4. What I'm going to do is I'm going to set a step 2, set a variable equal to that. Number 3 says figure out the place value of the repeating. The 5 in the tenths place is repeating. So since this is the tenths, I'm going to multiply both sides by 10. So 10 times x is 10x. When I multiply something by 10, it just moves the decimal once. So this becomes 5.555. Next step, we did step 4. Step 5 says subtract x from both sides. We're going to subtract 1x. Since x is equal to this junk up here, and I want to get rid of that junk down here, I just subtract it. So x is actually equal to the stuff we said equal to before. So we're going to subtract. I'm not going to write x over here. I'm going to subtract this over here. Remember, this goes on as many places as you want. You can keep going that. 10x minus an x gives me 9x's. Now all this junk goes away because when I subtract 5 from 5, it goes away. So I'm left with just 5. To get x by itself, I would divide by 9. 1 on the left, so it leaves me x equals 5/9. And there I have it. There's my decimal, my fraction from the decimal. Let's practice that with slide 6. This one has a whole number in front of it. We're going to ignore this whole number for a second and just use the 18, repeating 18. So I'm going to set my variable equal to expanding that a few spots out, 0.18181818. Goes on forever. What's repeating? Not the 10th spot, but the 100th spot. That's the 100th. So I'm going to multiply both sides by 100. And I'm going to show it like that, multiplied by 100. So I get 100x equals, now that's going to move it 2 spots. So 18.1818 goes on forever. Next step says to subtract x from both sides. So I'm going to subtract x on the left. And on the right, I'm going to subtract what x is equal to, the numbers that it's equal to, because it makes more sense to subtract numbers from numbers. This gives me 99x equals, all this jazz goes away, simplifies to 0. 18 can divide both sides by 99. X equals 18 over 99. I know that a 9 goes into both of those. So this would be 2 over 11. There we go. Yeah, 2 over 11. There we have it. There's another one. And, oh, missed it. So here's another one that we have, and I think if you need more practice, we can do more. We'll do one more, and this one's a little bit different. This is similar to the other one. I'm going to do this one, and then the rest I'm going to leave blank, and if you have questions, come see me. So this one, I'm going to set x equal to 0.04040404. Goes on forever. What's repeating is not the 10th, but the 100th. So I multiply both sides by 100. I'm going to show it like that. So I get 100x equals, moves the decimal, to 4.040404. Next step says to subtract an x. Subtract an x on the left side and subtract what x is equal to on the right side, so that this stuff behind the decimal can go away. 100 minus 1x is 99x equals 4. Divide both sides by 99. I get 99 to simplify to 1, and I get x equals 4/99. Is there a pattern? Yes, there is, if you can figure it out.